All right, on today's episode of Python Papi, we're back inside our TensorFlow course and we're still doing our malaria covnets module. Let's have a look at what we went over today. Now, yesterday, if you recall, the last thing we went over was getting the output for our 3D image, and today we're going to pick up where we left off. So from here, we will be moving into an explained visually project by Setosa. Filtering is a part of image processing, and since we are dealing with image data, it's important for us to understand how this works. If we have an image that we're filtering over, you will notice that no matter what the image is, we would always get an output with the outlines are being highlighted. Let's imagine that we have an image and the output is basically a black screen with the outline of an image drawn on it, with just the edges highlighted. And move down a little bit. The explanation says that the filter highlights large differences in pixels values, which generally occur at the edges. So around the regions of the edges, we would see the large differences are being outlined as compared to the rest of the image, which is just in black screen, and there is no difference. And since there is no difference, we would just have the black region. The major difference between what we are doing, major difference between what we are going to do here and the convolutional neural network is that with this, we know the kernel filters values. So for example, we would know that we would have the metrics -1, -1, -1, 8, -1, -1, -1. Kernel filter elements inside our 3x3 kernel filter, which is an edge detector. And because we know this, for example, we would be able to obtain our output. But with the CNN, our convolutional layer, to be specific, what we would do initially is just initialize these values and we would let the model do training to learn these values automatically. So these values are learned by the model during training automatically. Now, one of the very first CNNs or covenants was built by Young Yukon in 1989. Now, actually, we're just going into information about when it was created and different things you can do with it. We did take a lot more notes. Let me see if I can move down and get into a little something more interesting. Okay, so here we are here. Let's look at this here. So now for the AlexNet. It was built to correctly classify whether an input image belongs to one of 1,000 classes in the ImageNet dataset. And so we would have the AlexNet with a different architecture. And now we'll get into the understanding of how the outputs are obtained. And so we'll be rebuilding the Linnet architecture by this time around using it, but this time around using an input of 64 by 64 by 3. So we have the RGB channels. Here we have our RGB. You can see we have our RGB, our 3 different channels, and this is going to be a 64 by 64 by 3. If we pass this input through this convolutional layer, all of this here, this convolutional layer here, we are going to get this output here. So you see we went from the 3 by 3 or the 64 by 64 by 3, and now we have a image of 6 layers. They're not labeled yet because we didn't get that far. It was hard enough even just drawing these boxes together like this to get our network. But yeah, this is 6 instead of the 3. And to know it's 6, you can count our points. 1, 2, 3, 4, 5, 6. Yeah, so that's where we left off at for the day. Like I said, I don't want to move too far ahead because I want to make sure I have a grasp on everything. But we are moving right along. Of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.